Okay, we are exchange student group and my name is Peng Wu. My group member is senior 2. And now I'm going to introduce memory. So what about this? We need to learn some memory hierarchy. So here you can see registers are storage units located within CPU. They are fast but have smallest capacity. Cache memory is situated between the CPU and the main memory. It's slower than register but much faster than primary memory. RAM is the memory directly accessed by the CPU. It has large capacity than the register and the cache, but it's lower. Second memory is used for long-term data and program storage. What about the memory to memory management? So this is the task of the subdivision is carried out dynamically by the operating system and is known as memory management. Here you can see the two goals. The first one, carrying out the task subdivision dynamically and allocate memory for ensure reasonable supply of ready process to consume available process time. And what about the requirements? I mean, what memory management should do? The first one is relocation, protection, sharing, logical organization, and physical organization. The first one about load relocation. What about that? Once a program is swapped out of the disk, it would be quite limiting to specify that when it is next swapped back in, it must be placed in the same main memory regions and before. So after the program, another reason is about after program is loaded into memory, and all internal memory of reference must point to the correct location of the program in the current physical memory. Protection. Each process should be protected against unwanted reference by other processes, whether accidental or intentional. It achieves three goals. The first one is prevent authorized access, and the second one prevent cross-process instruction execution. The last one is protecting the operating system. Sharing. Any protection mechanism must have the flexibility to allow several processes to achieve the same portion of memory. Advantage is to allow each process to achieve the same process of the program. And the logical organization is the main memory and the computer system. It's organized as linear and one-dimensional address space consisting of sequence of bytes or words. Physical organization is include main memory and second memory. And the next part is about memory partitioning, fixed partitioning. So here, what it is, it's divided available memory in regions with fixed boundaries. Partition of equal size. Any partition smaller than the equals to the partition size can be loaded into partition. And here you can see a very obvious internal fragmentation is space west, caused by the loading data blocks more than the partitions. And what about another one? Another concept is also similar to fixed partition, varying partition size. The difference is, can each process be allowed to the smallest partition it can accommodate? The disadvantage is the number of partitions specified as system generation times limit the number of active process in the system. And okay, here you can see dynamic partitioning. Dynamic partitioning is different with the viral partition, varying partition, and fixed partition. It means the length of partition is the variable allocated as much memory as the process requires, and the obvious disadvantage is external fragmentation. It leads to a situation in which there are a lot of small holes in memory. So it will lead to memory utilization. I'm sorry, I mean the memory utilization will decline. And this table is strengths and weakness from the books. And The last part about paging. Paging is the chunk of process known as page could be assigned to variable chunks. Memory is known as frames. Page table is the shows the frame location for each part of process, and the logical address is a virtual address. It's generated by the program, and physical address is an actual address in the memory hardware. So the process is when a process executes, the operating system dynamically leads the process page into available memory frames without requiring contiguous address allocation. A page table is used to map each page to a specific physical memory frames. The CPU generates logical address, which is then translated to physical address used into page table and access memory. And here you can see the advantage is no external fragmentation for paging, but the disadvantage is a small amount of internal fragmentation. Okay, this is my part.
Hey, I'm Tu Xinye, and now I'm introduce my part. First is virtual memory and paging algorithms. First is define the concept of virtual memory. Virtual memory is a memory management technique that makes programs think they have continuous memory, even when physical memory is fragmented. And then it's explain how virtual memory allows programs to use more memory than physical memory. When physical memory is sufficient, the operating system moves less used data to the hard disk to free up more memory for active programs. Then is discuss how virtual memory is implemented through paging and page fault handling. Memory is divided into fixed size pages if the data program needs is not in memory. A page fault is triggered and the operating system loads the page from the disk. And the second one is paging algorithms. First is review different paging algorithms. There are 4 algorithms. The first is optimal algorithm. It selects the page that will not be used for the longest time in the future. And then is FIFO algorithm. The first page that entered the memory is the first to be replaced. Simple but efficient. And then is ARU algorithm. It's good performance but complex implementation. And then it's clock algorithm. It's similar in efficiency to ARU, but it's easier to implement. And then it's compare the performance of paging algorithm. I think the best in this theory is optimal algorithm, but it's impossible to implement. And then ARU is good performance but complex. And then it's FIFO. It seems to implement but unstable efficiency. And the last one is clock algorithm. It balances performance and implementation complexity, so it's suitable for real systems. And the third one is advanced memory management and techniques and performance optimization. The first is discuss the resident set management strategies. First is fixed allocation and the variable allocation. For the fixed allocation, each program gets a fixed amount of memory, simple but not flexible. And then is variable allocation. Memory size adjusted dynamically. Improves performance but is complex to implement. And then local replacement and the global replacement. Pages are replaced only within the program, avoiding interference. And global replacement pages can be replaced across all programs, higher resource usage but possible contention. And then describe techniques for dynamically adjusting the resident set size. The first is working set model. Is how it works. It monitors the pages a program uses and adjusts memory allocation dynamically. And then is page fault frequency algorithm. It increases memory when page faults are high and decreases memory when page faults are low. And then is how cache memory affects memory performance and interacts with paging and virtual memory. First is how it works. Cache memory stores frequently used data for faster access. And then is cache levels L1, L2, and L3 cache speed up data retrieval. And then is cache hit and cache miss. Cache hit is data found in the cache, fast access. And cache miss is data not in the cache, slower access from memory. And next is interaction with paging and virtual memory. Paging system, the memory is divided into pages. And address translation is CPU checks the TLB first, then the page table if needed. And then is cache updates when pages are swapped. And then is performance impact for the better aspect. It has fewer page faults and faster memory access. And in the worst aspect is more cache misses and slower performance. And that's all. Thank you.